All right, let's pull back the curtain on something really cool today, supervised learning. This is one of the most powerful kinds of AI, and you've probably used it a dozen times today without even knowing it.
So let's start with a real world question. How does a bank know if you're a risky borrower? I mean, when you go to apply for a loan, how do they really decide? Is it just some person's gut feeling, a roll of the dice?
Yeah, no way. It's not magic, not at all. It's actually a super calculated prediction. And it's powered by a specific kind of machine learning that gets really, really good at predicting the future by studying the past.
Okay, so that brings up the big question. How do you even teach a machine to do that? Well, the best way to wrap your head around this is to imagine the AI is a brand new student. It shows up on day one, a total blank slate, and it's up to us to be the teacher. So, how do we teach this AI student? This is where supervised learning gets its name. The secret sauce is the answer key. We don't just hand our student a bunch of problems. We give it the problems and all the correct answers right from the get-go. Okay, so the official definition is that supervised learning is a machine learning approach where models learn from labeled data. Labeled data is just a fancy way of saying data that already has the correct answers attached. Every single question comes with its correct answer. And this is where that student analogy really clicks, right? It's like you're giving a student a giant stack of math flashcards, but on the back of every single card, the answer is already there. The point isn't for the student to just memorize the answers on those cards. The real goal is for them to figure out the method, the why behind the answer. So the whole learning process breaks down into a few steps. First, our AI student just observes. It looks at thousands, maybe millions of examples. Here's the problem, here's the answer. Then it starts to connect the dots. It's looking for patterns, tweaking its own internal wiring to figure out how you get from A to B. And finally, after seeing enough examples, it gets good enough to see a brand new problem and predict the right answer all by itself. And this gets to the absolute core of it. The real power here isn't memorization. Any computer can do that. The magic of supervised learning is its ability to generalize from what it's seen. So what does generalize actually mean? It means that after studying all that data with the answers included, the AI can be faced with a completely new problem, something it's never ever seen before, and still have a fantastic shot at getting it right. It didn't just memorize the answers, it learned the rules of the game. Okay, so we've put our AI student through boot camp. It studied hard, but like any good teacher, we have to ask, did it actually learn anything? So it's time for the final exam. Let's talk about how you grade an AI. I mean, this is the whole point, isn't it? If we just give it the same problems it studied, all we're testing is its memory. What we really need to know is if it can think on its own. And the solution is pretty straightforward. We give it a test. We hit it with a bunch of brand new data, stuff it was never shown during its training phase. This is its moment of truth. And how it does on that test generates its report card. But this isn't graded on a curve. We use really specific, cold, hard metrics, things like accuracy, recall, and precision, to get a clear picture of its performance. So let's quickly unpack what some of these grades mean. Accuracy is easy, right? It's just, what percentage of the time was it correct? But then you have things like recall and precision, which are a bit more nuanced. Let's use spam filters as an example. Recall asks, of all the spam emails that actually exist, how many did our AI successfully catch? You want that to be high. But precision asks something different. Of all the emails our AI said were spam, how many of them were actually spam? You see the difference? You want to catch all the spam, but you definitely don't want to mark an important job offer as spam. It's all about finding that perfect balance. All right, so our AI student aced the final. It's graduation day. Now it's time to get a job and see what this thing can do in the real world. Yep, once a model proves its worth on that test data, it's ready to be deployed. It's time to put it to work making real decisions that have real consequences. And these AIs are qualified for some pretty important gigs. We're talking about things like classification. Is this a picture of a cat or a dog? Is this email spam or not spam? And scoring. Is this a high-risk or low-risk investment? So let's bring this whole thing full circle, right back to where we started, the bank loan. This is a perfect textbook example of a scoring job for a supervised learning model. So for this job, what did the AI's study material look like? Well, it would have been fed thousands and thousands of past loan applications. Some of them would be labeled default, these are the people who didn't pay it back, and the others would be labeled no default, the people who did. By sifting through all of that historical data, the AI starts to learn the incredibly subtle patterns linked to both outcomes. So now, when a new application comes in, it can look at the data and predict, with a pretty high level of confidence, which of those two buckets that person is likely to fall into. And for the bank, the payoff is massive. It automates what used to be a really complicated decision. It cuts out tons of manual effort, and it just makes the whole operation way, way more efficient. So when you boil it all down, what's the big takeaway? Supervised learning is really just about this one simple idea. You teach a machine by showing it the right answers over and over and over again until it finally gets the underlying patterns and can find those answers for itself. Look, this method is so powerful because it has that perfect answer key, right? It's learning from a history of what's correct. But it does leave you with a pretty mind-bending question to chew on. What happens when you want an AI to learn something new? Something where there is no answer key? What can an AI possibly learn when there are no right answers to study from in the first place?